Here we are going to discuss modular arithmetic. In our previous lecture series, we have already discussed some basic part of the modular arithmetic, and here we are going to continue our lecture series. The modular arithmetic is one of the main tools provided by number theory, and the quotient of n divided by m is the greatest integral value of n by m, where m and n are positive integers. The remainder of this division is called n mod m. So the following holds, where the first term is quotient and the second is remainder. So n equals m, n by m plus n mod m. Here this symbol is used for the integral value of n by m. The another way of putting this is, given any positive integer n and any integer m, if we divide m by n, we get an integer quotient q and integer remainder r that obey the following relationship: m equals q1 plus r. Here this is simply the division algorithm, where m equals the dividend, q is the quotient, n is the divisor, and r is the remainder. Here r is greater than or equal to 0 and less than n, and q equals the greatest integral value of m by n. The remainder r is often referred to as a residue. This is very important point, residue. The remainder r is often referred to as a residue of m modulo n, and is the smallest non-negative integer that differs from m by a multiple of n. For example, if m equals 11 and n equals 7 and 11 is equal to 1 into 7 plus 4, then r is equal to 4. Here simply, when 11 is the dividend and here n is equal to 7, so here r is the remainder, because when we divide 11 by 7, then the quotient will be 1 and r will be the remainder. Same here, m equals minus 11, n equals 7, minus 11 equals minus 2 into 7 plus 3, r is equal to 3. Here are some important points, like two integers a and b are said to be congruent, denoted by this notation: if a is congruent to b mod m, a mod m equals b mod m, that is, a is congruent to b modulo m. Alternatively, in arithmetic modulo m, a and b are equivalent if their difference a minus b is a multiple of m, that is, m divides a minus b. Here this symbol, this is the symbol of divisibility, like m divides a minus b. The set of integers zm equals 0, 1, 2, 3 up to dot m minus 1 form the complete set of residue modulo m. There are only m different integers mod m. The operation a mod m denotes the residue of a such that the residue is some integer from 0 to m minus 1. This operation is called the modular reduction. We are just revising. The operation a mod m denotes the residue of a such that the residue is some integers from 0 to m minus 1. This operation is called the modular reduction. Like if 10 is congruent to 2 mod 4, so here 10 is divided by 4 and gives remainder 2. So here 4 divides 10 minus 2. Here 4 divides the difference of 10 minus 2. So we can write this as in the form again. Here is the modular arithmetic.